Hi there, I'm Hao, and this is just another video of me solving random code problem. So let's begin. We have edit distance today. So we are given two string word one and word two. We need to return the minimum number of operations required to convert word one to word two. And we have the following allow pre-operation: insert, delete, and replace. So we have two words here. Right, we're gonna start at the length of each word. So uh, the first approach, we can just use recursion to solve this. Right. So what is our base case? Our base case is that if we have something in word one, right, and just like nothing in word two, then in that case, we can just return the length of word one, right? We need this many number of operation to convert word one into word two, right? And vice versa, if we have an empty string on the left on word one and something on word two, right? And we return the line of word two because we need this many operation, right, to convert word one into word two. So that is our base case. So an empty string in other word, if in index one and index two, so is equal to 0, then we will return the other index. Right. So it will start out at the length, next one, and then we have index 2 setting out here, right? Okay, so when we check, we always check the letter at word 1, index 1 minus 1, and word 2, index 2 minus 1. We always check because we start at the length, right? So we need to go back one. So like letter E and letter S here. So they are different, right? So if they are different, then there are three things we can do. We can either insert, delete, or sorry, delete, right, or replace. So if we insert a letter here, what does it mean? Which means that because so we go converting word one to word two, so E is not equal to S, right? So to insert, we can insert the letter S here, right? So if we insert the letter S here, index one stay the same, right? But index two, we can move on to the next characters, right? So in this case, index one stay the same because we insert a new letter at that index, right? But index two, gonna go back one, right? Because we want to move on to the next characters for comparisons, right? So replace, um, so let's go back here. Okay, so we'll compare E and S again. So because they are different, right? We can replace the letter E with the letter S. So we can say E become S, right? And if we replace the characters right now, they are the same. So we can move on to the next characters by decrementing index one by 1 and decrementing index 2 by 1 so that we can compare the next characters, right? The third option is we can either delete. So what's the delete means? So delete means that we can, because E and S are different, so we can just delete letter E entirely, right? And then move on to the next character in word 1 to find a letter that is equal to letter S here, right? So in that case, index 2 going to stay the same, right? Because we are deleting a letter in word 1, right? We are trying to find a letter that is equal to the current letter we are looking at in word 2, right? So index 2 gonna stay the same, but index 1 gonna go back by 1, right? Right. So this is a backtracking problem. We have 3 choices to go when the word is different, right? And we just had to choose the path that have the minimum operation, minimum number of operation, right? Okay, so let's just work through an example here. So again, right, E is different than S. Remember, we always compare index. We're gonna go back by 1 index for comparison because we start at the line, right? So E is different than S. So what do? We can take 3 paths, right? So the first path is insert. Right, the first path is in insert. So we're gonna have H O or S. So if we insert, right, yeah, so let's do this. So we have 3 paths, 3 paths, oh, 3 paths. Okay, so the first path is insert. So in next one, I'm gonna stay the same. So it is 5. And then in next 2, I'm gonna go back by 1. So 3 minus 1 is 2. Right. The next one is replace. So we replace, we move on to the next characters in both word. So this become 4 and 2, right? And lastly, if we delete, um, become 4 and 3. And we need to add 1 to the operation. So this is one operation, right? This is one operation. It is one operation. It is one operation. Okay, so let's keep going here. So now we have 5 and 2, right? Let's explore this path. 5 and 2. So 5 and 2, which is here, 5 and 2, right? So we'll compare uh letter E and letter O, right? Because they are different again, we can take 3 paths, right? So the first path is 5, 1, which is insert, or 4, 1, right? Which is replace, right? And the last one is delete, which is 4 and 2. Okay, so let's keep going here. And don't forget, each um yeah, each level wanna be an extra operation, right? Either this operation, or this operation, which is a combination that give us the minimum number of operation. Okay, so let's keep going. So let's look at this. Find 1. So which is this one right here. Find 1. So we are comparing E and R, right? So because they are different, E is different than R. So again, we detect another 3 path. So this is 5 and 0, right? It is going to be 4 and 0. It's going to be 4 and 1, right? It is another operation here, okay? And then now, because index 2 is 0, right? Because index 2 is 0, index 2 is 0, and then index 1 is 5. So index 2 is 0, which means it is an empty string, right? So if it is an empty string, we need this many number of operations to convert word 1 into word 2, right? So we can just go ahead and return 5. Return 5. Return 5 operation. So this is our base case. Same over here. We're gonna return 4, right? Right. Um, and for here, right, we need 5 operation at this step plus the 1 operation that we're gonna go down earlier, right? So we're gonna return like 6. So this is gonna be a 6th operation, right? This is gonna be 4 plus 1 is oh, you know what? Let's go back a little bit. So it is 5, it is 4, right? We need to pick the minimum operation plus 1, right? The one operation is the one we go from this level to this level. Okay, so let's just finish out this range for 4, 1. So if we have 4, 1, so something like this, 4 and 1. Good. We're gonna stack 3 step again, 4 and 1 because F is different than R, right? So we can go 4, 0, right? Or 4, 0. Wait, hang on. 4, 0 or 3, 0. Yeah, 3, 3, 0. For this one is 3 and then 1, like so on and so forth. Right. This we're gonna return 4, return 3, and this we have to keep going, right? Right. So the point is that we the point is that we need to keep track of so the point is that we need to pick the minimum number of operation. So when we return back up, right? So let's say we have 5. Let's say between this path and this path, right? This path give us 5 operation to convert one into a 2. This path give us 4, right? So we're just gonna pick the minimum, which is 4, right? Right. And we need to add 1 to that and then just return back up, right? Right. In the case that if the two letter are the same, right? Let's say we are starting out at 5, right? Uh, let's let's say we're starting out at 5, it is 3, right? Let's say if they have the same letter, E and E, right? So in that case, we're just gonna so that if the letter are the same, then there's no operation needed to convert, right? So just decrement the index 1 and decrement index 2 by 1, just like the replace case, and then keep going. Okay, so that code is up. So the time complexity for this gonna be because we have 3 paths, right? Because we have 3 paths, so our time complexity gonna be 3 to the n, right? This way gonna be on. So what is n? N is gonna be the max between the word 1 dot length and word 2 dot length. So we can have a helper function here. It's called calculate distance, taking index one and index two, right? And we can start out at the length. So one dot length and or two dot length. Okay. So our base case is if index one is zero, right? We will just return index two, and if index two is zero, then we can just return index one, right? So that is our base case. The third base case is gonna be not really a base case, but a recursive case, right? So if the letter are the same, so if word one, index one minus one is equal to word two index two minus one, right? If the letter we are currently comparing are the same, in that case, we don't need any extra operation. We can just move on to the next character. So we can return, calculate distance, move on to the next letter, just like that. Okay, so if they are not the same, then they are different, right? In that case, we have three choice, right? We can do insert operation, right? Right. We can have replace operation, right? Or we can do delete operation, delete operation, right? And then we just have to take the minimum path, right? The path that give us the minimum number of operation. So between insert operation, replace operation, and delete operation, right? Like that. So what is insert? As mentioned earlier, insert mean we insert the letter in the word one, right? So in next one, I'm gonna stay the same, but in next two, we can move on to the next characters. For replace, right? We have to move both index, yeah, because if we replace a letter, then they are the same, right? So in that case, we have to move on to the next character in both words. And the third option is delete. But if we delete, then we need to move index one, but index two, we want to stay the same. Oops. Index two. Okay. And yeah, that's pretty much it. Let's give it a try. So it is accepted, right? But it is not an optimal solution. It's pretty slow. So let's just copy this, right? So um, we can improve by just using dynamic programming, right? So if we use dynamic programming, we can reduce the time complexity to n1 multiplied by n2. This way, gonna also going to be n1 multiplied by n2. So it is the trade-off, right? We can give it some space, but we're gonna significantly improve the runtime. So let also call this n1 just for consistency, n2, right? So do this n, this n. Okay. So uh, so as you can see, we might end up with a lot of repeating substring, right? So instead, we can just store our result here before we return, right? We can just store the result in our memo, right? Let's call this memo, right? Memo of index one and index two, memo of index one and then index two, right? And then we can just return it at the end, return memo index one and index two. So in that case, we can avoid a lot of repeating substring, right? You have to add another base case here. So if we already have this task between index one and index two, right? Then we just want to return memo index one or index two, right? Because if we all add this letter, sorry, if we all add this index in letter in word one and this index is in word two, right? They're gonna just have the same number of operation that we calculated earlier. So that is that, and we need to create the memo, right? So let's do that. So we have n1, right, is our one length, right? Word two, n2 is word two length, and then we need to create our memo array equal to array dot from, right, with the length of n1 plus one, and separate with the length of n2 plus one, and they can start out at no. Okay, so we can just use a 2D array here. Yeah, and then this is going to be n1, and this is going to be n2. All right, so we don't do anything special here. For approach 2, we just have to create a 2D array for n1 and n2, right? And then before we return, we just store it in our memo and then return it, right? So every time we go to the next level recursively, we just have to check if the combination of these two index is in the memo. If it is, we just return, like, instead of spend extra time going down that path again. So let's give that a try. Okay. So this approach also work. Okay. So this is the DP recursive approach, but we can do a little bit better, right? We can to the third approach, right? We can go bottom up population, right? The space and the time gonna be the same, but generally we would avoid recursion in production code because it's very factorial for Stack Overflow. Okay, so for the tabulation approach, like, what can we do here? Okay, so it is a little bit tricky to come up with, but generally we're gonna have word one, right? The index here, and this is gonna represent the word two. Or like it's gonna represent the number of operation depending on the index. So our memo, right, it's just a 2D array, so it is just the same thing, and the value gonna represent the number of operation to convert word one into word two. If we start at this index, is this combination of index, right? Or let's say if we have four, so zero. So let's say I zero. Okay, so I'm gonna have 0, 1, 2, 3, 4, and 5. Right. It is word one and word two gonna be 0, 1, and 2, right? So in this column, if word two, right, is 0, right, then the number of operations to convert word one into word two just gonna be the length of word two, right? So if word one is have one letter, then we need one operation, right? If word one is 5 letters, then we need 5 operations to convert word one into word two, right? If word two is empty, right? Similarly, if word one is empty, then depending on the length of word two, we need this number, many number of operations to convert word one into word two, right? So right at each, it's just gonna start from index one, one and one here, right? In here, right? So we just compare, right? The letter for one, right? At index one minus one, right? And then you compare it with the word two of index two minus one, right? Which is like the letter like diagonal like that, right? If they are the same, like we don't need any extra operation, right? Right. If we don't need any extra operation, we're just gonna store, just gonna take the operation that we already have previously, right? But if they are different, right, then you can check the minimum, right, of three. So and then plus one, right? So if we replace, right, if we replace, right, we're just gonna take the old operation plus one, right? So this is gonna be replace, right? This gonna be if we keep index one the same, if we keep index one the same and index one the same and index two minus one. So this one gonna be insert, I believe. Oh no, sorry. We keep this one the same. Yeah, but this one is same. We will go back one, right? The same. Go back one column. Yeah, so this is gonna be insert, right? Insert, and this is gonna be delete. All right, for delete, we keep index to the same, right? But index one, we need to go back one by one, right? So we just check the minimum number of operation, right, between these three paths, right? Replace, insert, and delete, and we're gonna add one plus one, right? Which is for the current operation, and we're just gonna build out the whole to the array, right? And then at the end, we will return, right? Because what we want is uh, the DP, right, at N1 and then N2. Okay. So let's code this up. So first thing first, we need our N1 and N2 or one of length, and then N2 equal to word two length, right? And then our TP gonna be to the array, right? Dot from length is N1 plus one. Subarray gonna be array that from length of N2 plus one. Oh, there's a typo here. Right. Yeah. Okay. So we need to fill out the array first, right? For the first row and the first column. Right. This is gonna be equal to the length. Same thing here for N2. But this is gonna be the column. Okay. So now we have to iterate to the whole to the array. So we're gonna be out the DP at index one and index two, right? Is if the letter, right, the current letter we're looking at are the same. So index one minus one is equal to or two, index two minus one, right? If they are equal, right, we're just gonna take the one diagonally, right? Remember, we're gonna just gonna take the previous number of operation, right? And we start out at zero. Remember? So it's just gonna be dp at index one minus one and index two minus one, right? If they are not equal, uh, let's see. Let's make it a little bit more readable here. If they are not equal, right, we're just gonna take the method min of the three options, right, plus one. Okay. So index two minus one. So it's gonna be insert, right? dp index one minus one, uh, index two minus one. So it's gonna be replaced. And then lastly, index one minus one, and then index two. So this is gonna be delete. Right. All right. And then at the end, we just have to return VP at N1 and N2. Okay. So this is pretty much it. Let's give it a try. It worked. So thank you for watching.